Good morning. Today our topic is going to be similar shapes, area, and volume. First, we need to discuss similar shapes. Are these two shapes similar? Two shapes are similar if they have the same shape. Their angles are equal, but their lengths of the sides may be different. When two figures are similar, the ratios of the lengths of their corresponding sides are equal. So we need to find which sides are corresponding. We can see that this side should be the corresponding side for this, the base with the base, and the hypotenuse with the hypotenuse. We set up our ratios and check if they're equal. Is AC equal to DF? AC is 10, AB is 6, DF is 5, and DE is 3. So that's how I create these two fractions. The base with the base, 10 to 5, and the height with the height, 6 to 3. And then I want to see if these are equivalent fractions. And we know that we can divide the top and bottom by 2, and they are in fact equivalent fractions. So these are similar shapes. Example 1. They give you two shapes and they tell you they are similar. Find the length of the missing side. The first step is to find the scale factor. That means what number do I multiply this triangle by to get these lengths? So I have to divide to find that. I do 7.5 divided by 3 and I get 2.5. This is known as the scale factor. I can use this scale factor to find the length of the missing side. 12.5 times the scale factor of 2.5 will give me D, and 4 times the scale factor will give me C. 4 times 2.5 is 6, and actually for the other one, we're going from a smaller triangle to a larger triangle, so we have to divide by the scale factor. When you're going from small to big, you multiply. When going from large to small, you divide. So 12.5 divided by 2.5 is 5 centimeters. And we knew that D had to be 5 centimeters because we know that is a 3, 4, 5 triangle. On your own, find the lengths of the missing sides. Similar areas. Let's explore what happens when we find the area of similar shapes. We can see that the scale factor is 2. But what about the area? Well, the area of the smaller square is 1 times 1, so the area is 1 inch squared. The area of the second square, the larger one, is 2 times 2, which is 4 inches squared. So we see that when we find the area, we actually are multiplying it by 4. It is 4 times as large, and it is in square units. Now, 4 is actually equal to 2 squared. We can use this as a rule for similar areas. To find the area of similar shapes, we multiply by the scale factor squared. So in this case, we would have used 2 squared as a multiplier instead of 2 to find the area. Example 2. These two shapes are similar. Find the area of the larger triangle. So they give us the area of the smaller triangle, which is 4 feet squared, and they give us the ratio. The ratio here is 2 to 9. The first step is to find the scale factor. 9 divided by 2 is 4.5. The second step is to square that number. 4.5 squared is 20.25. And the third step is to multiply the area of the smaller shape by the scale factor. So 4 times 20.25 is 81 feet squared. On your own, find the area of the larger shape. Round your answer to the nearest 10. Similar surface area. Surface area, we know, still uses square units, and so the same rules apply as area. We find the scale factor, we square that number, and we use that as a multiplier. Example, these figures are similar. Find the surface area of pyramid A. So the first step, we're going to find the scale factor. 18 divided by 6 is 3. Step 2, square that scale factor. 3 squared equals 9. Step 3, divide the area of the larger shape by the scale factor. Now again, we're going from larger, they gave us the larger, they're asking for the smaller one, so we need to divide. 600 divided by 9, rounded to the nearest tenth, is 66.7 feet squared. Miss Ariel forgot her units. Note, when going from a smaller shape to a larger shape, they're asking for the larger shape's area, we need to multiply. When they're asking us for the smaller shape's area, we need to divide. Going from big to small, we'd have to divide. To go from small to big, we'd have to multiply. Similar volumes. Let's explore what happens with volume. We can see that the scale factor again of the faces are 2. 1 times 2 is 2, so the scale factor is 2. But what about the volume? The volume of the smaller cube, 1 times 1 times 1, gives me 1 centimeter cubed. The volume of the larger cube is 2 times 2 times 2, which is 8 centimeters cubed. The volume, therefore, is 8 times larger than the smaller cube. 8 equals 2 to the third power, which we saw, 2 times 2 times 2. This happens because we're multiplying 3 numbers together. We know volume uses cubed units. We can again use this as a rule. To find the volume of similar shapes, we multiply or divide by the scale factor cubed. So in this case, we would have had to multiply by 2 to the third power. Again, it shows us here, solid A, solid B. We write it as a fraction, and we cube that number. Now we reduce it when I say we divide to find the scale factor, but sometimes you can leave it as a fraction if it's not an even number. Example 4. We're told that these two cones are similar, and they've given us the volume of the larger one and have asked us to find the volume of the smaller cone. First step, we find the scale factor. The radius of the larger is 5, the radius of the smaller is 2. So we divide. 5 divided by 2 is 2.5. Step 2, we're going to cube this number. That means raising it to the third power. 2.5 to the third power is 15.625. Because we're going from a larger shape to a smaller shape, we need to divide by that scale factor. And 8,000 divided by 15.625 is 512 meters cubed. Now, you try some on your own.